And of course, the raffle that we just mentioned for that excellent way to back up your data, protect your information, and that'll be raffled off at the end via questions you submit in the question control panel. So, what's news? If you've ever been to one of my webinars before here, you know we like to start out with what's trending in the industry right now. Not necessarily on Twitter, but here at DriveSavers. There was a press release just in the last couple weeks. I don't know if any of you had seen it, but a great story about DriveSavers helping out an excellent gentleman, a professional photographer, Sal, who was doing a great job of protecting all his very valuable professional photography images, his income. However, was not protecting his laptop, which of course was also vulnerable with a single point of failure in it, and lost that device. He came to DriveSavers. Long story short, it was a very successful recovery with a very happy customer. And in the end, he's got 700,000 files recovered off his laptop that he'll be protecting in the same way he protects all of his important image data moving forward. Go ahead and look that story up if you get a chance. It's an interesting one. Very interesting as well, especially in our world of solid state drives and what's happening in storage. As we all know, there's only 3 hard drive makers really left in the world, Western Digital being one of them. They just invested very heavily in Skyera. Skyera is a disruptive technology in the enterprise SSD market. They're actually doing a new type of RAID called RAID SE, where they're able to use MLC grade NAND flash and be able to produce it in an enterprise environment at about $3 a gigabyte, which is actually quite inexpensive. What's very interesting about Skyera is that the company is founded by Radoslav Danilak, who, if you know, is the guy who founded SandForce, now LSI, the dominant player in the SSD world. So very interesting investment from Western Digital moving forward into enterprise RAID storage in SSD. Samsung, of course, had a very big announcement just a couple of days ago. As we know, everybody was waiting for the new Galaxy announcement and whether or not it would really dominate the smartphone market. There are some opinions both ways on how excellent that device is, but I know it will be very popular. And of course, we'll end up recovering it here in the laboratory as well. Samsung is doing a great job of dominating the mobile phone space right now, with Apple very close behind. And of course, how could we forget the brand new BlackBerry Z10 that everyone is waiting for? Or at least some people are waiting for it. We'll see what kind of traction it gets in the marketplace now that the US release date is pending, and whether or not we end up seeing them here in the laboratory for data recovery, which I assume we will. So let's dig a little deeper into these new trends in storage in SSD. Big news right now, of course, as you're probably well aware, is that the prices are dropping significantly on SSD and NAND flash storage. $3 a gigabyte just a couple of years ago. We're definitely under $1 a gigabyte right now on a lot of devices in the consumer and the prosumer space. I did a quick survey just this morning, popped on a Newegg real quickly and said, show me everything that's 120 to 240 gigs. And when you see some of the pricing there, we're looking at around 70 cents, I think, 75 cents or so a gigabyte on these brand new SSDs, regular pricing from Newegg. It's pretty impressive that we have broken that threshold of $1. And now the industry is saying, let's get to 50 cents. Now let's keep in mind hard drive pricing, depending on what you're looking at for drives, is 10 to 20 cents a gigabyte. So hard drives, of course, are still cheaper than solid state drives. And the gap isn't necessarily closing, but solid state drives are becoming much more affordable. So how and why is that happening? Well, part of that is because of what's called TLC NAND. So let's do just a real quick history lesson on NAND flash. SLC was the single layer NAND flash, which was very reliable, very robust, very expensive, very fast. It could handle over 100,000 writes per data cell, but that is a minority of the global market, mainly due to cost. MLC, which is the multi-level, has really taken hold, and that's 2 bits per cell. That is what's dominating the global marketplace for NAND flash right now. Interestingly, though, the endurance, when you're looking at that, is typically, depending on whose MLC it is, around 3,000 or 5,000 writes per cell, which is a low number compared to that SLC. Now there's the new category of enterprise MLC, which can do about 10 times that, maybe 30,000 writes per cell. But the news about TLC, which is 3 bits per cell, that's the big news moving forward. And it really will raise a much larger issue now about the endurance of SSDs. The reason being is that TLC NAND flash is cheaper to produce, has greater density, but has a very, very low program erase cycle limit, 1,000 to a couple thousand times per cell. So that raises that question once again of how long will these particular devices last that are using TLC NAND? And we're seeing Samsung shipping the new 840 series solid state drive in a pro version using MLC NAND, and in the consumer version for $100 less using the TLC NAND. So we know that we're going to see it from OCZ, and they may have a device out already, and Plex Store. So what we're seeing is that greater density and lower cost by using TLC NAND, but now we're seeing a real differentiation between what will be a consumer grade device and a prosumer or enterprise grade device. Very interesting stuff happening here. Watch for more news about TLC NAND. And of course, on the opposite side of the spectrum with flash is in the enterprise. Native solid state storage ecosystems designed from scratch to be all flash. We're seeing them in consumer devices from a bunch of vendors. G-Tech, I believe, has one. LaCie has one. Buffalo has one. We're looking at Thunderbolt attached devices here. Why are we now seeing solid state drives with Thunderbolt? Because you finally have a bus large enough to take advantage of the speed of the solid state drive. On the pure enterprise side, we see very exotic and sexy products from EMC, like the Extreme IO array. We're seeing brand new stuff from NetApp on the high end, and companies like Skyera and others who are entering the storage market purely doing flash. Really interesting stuff going on, both on the low end and the high end in flash markets. And just like Seagate said it was going to happen a few years ago, hybrid technology is getting some traction, and Seagate is driving that bus primarily. So let's look at hybrids for a minute. There's a picture right there of the latest generation, kind of a illustration more, showing flash and disk together, which of course is what hybrid technology is, marrying the best of HDD with the best of SSD into one single device. Seagate's brand new hybrid technology that was just announced in Generation 3 a couple of weeks ago is very interesting. They now are offering both a 2.5-inch notebook and a 3.5-inch desktop drive up to 2 terabyte capacity at very attractive pricing, with what the marketing literature says is about a 5x performance increase over regular hard drive. They're quite a bit cheaper than SSDs at the same capacities. And this in Generation 3 is using MLC flash along with the hard drive, where Seagate's now bringing the rotational speed down from 7,200 RPM on some drives to 5,400 RPM because they're getting the additional speed gain from the flash. Toshiba, Samsung, Western Digital also have offerings in this space, but Seagate's doing most of the work. The Apple Fusion Drive that we spoke about in the last webinar, of course, is Apple's solution to a type of hybrid technology. Of course, we kind of refer to that as the secret sauce, or the logical layer between the solid state drive and the hard drive, where they actually have 2 devices in a system, for example, in an iMac, where some of the logic used by Apple in the Fusion Drive software layer is managing that hybridization, really, between the solid state drive and the hard drive. There's the build to order option and user creatable configurations with disk utility. What's interesting here is that Apple put this into the iMac, where they could get 2 devices in there. And Seagate, just a couple months after Apple announces this, now has a desktop 3.5-inch hybrid offering. So you might end up seeing those in iMacs as well. Interesting stuff here, both from a manufacturer and from Apple on how they're doing it. And then, of course, you have Intel, who has really developed and is evangelizing the SSD cache technology, where they're selling that SSD as typically an mSATA-like device, which acts as a very high-speed cache. And it's on the i6 and i7 motherboards, Z68 chipset stuff, and they call it SRT, or Smart Response Technology. It's different than the way Apple does it with Fusion Drive, and there's quite a bit of info online if you want to kind of get nuts and bolts on how that stuff works. But both technologies have their advantages, and Intel's is very interesting as well. So let's jump over and segue into big data for a moment. Big data is relevant in a lot of ways for today, especially because you can't ignore the term anywhere in technology news. But it's very relative to what's happening with the SSDs and the flash. With all the growth in SSD and flash, we're seeing it really integrate into the big data markets. And let's try and define that a little bit better for us right now so that we know exactly what we're talking about when we hear the term big data. What you're really talking about is the massive amount of structured and unstructured data that is so large for a particular entity or a project that it's difficult to process using traditional databases and traditional technology. So, trying to wrap our arms around big data, it's a very dynamic, growing, expanding target. It also happens to be probably one of the most popular SEO search terms on the internet today. Everybody says they're in big data. Whether or not they really are, it was born as an internet term and now it's becoming an industry. When we think of examples of what big data is out in the industry or the field right now, one that's a hot topic, of course, is the Large Hadron Super Collider in CERN over in Switzerland. They apparently have now found the Higgs boson, or maybe they think they have. What's miraculous is to find that tiny little piece of science. They are processing over 25 petabytes of raw data per year, and that's only 1/1000th of the data they're sampling. If they actually saved everything from the last year to find that single Higgs boson, they would have over 150 million petabytes of storage just this year. Okay, this is what we're talking about with big data. The Human Genome Project, astronomical surveys, and then in a more tangible way, think of Amazon and the services they're offering, or think of Facebook. Facebook, this is a scary statistic, but they now have over 90 billion with a B photos of yours and mine and everyone else's online. They add about 200 million new photos a day. They tag those, they're geotagged, they're tagged all across Facebook. It's a lot of data to manage. That is another great example of big data. Why it matters to you? Well, it's a really big deal in science, technology, and healthcare. This is where huge advances are going to happen very quickly in genetics and other places where things that we couldn't even fathom 10 years ago can be completed in a short amount of time today when utilizing massive internet horsepower, huge server horsepower, and the concept of big data to kind of wrap a package around all of it. What the industry claims big data is really for is to reduce information overload, filter it down to the minute relevant pieces of information that are important to you or me. Unfortunately for industry, that probably means advertising. Fortunately for us as consumers, it means that we should be able to find what we're looking for more quickly with more accuracy. And in the data recovery lab, well, big data is going to mean big potential data recoveries. We don't expect to see a whole data center go down and come in here to DriveSavers, but what we do see right now, and what we will definitely continue to see, are very large databases on storage area networks that are part of a cloud infrastructure, part of a big data infrastructure, where a portion of that data has been lost or a significant database has been lost. So we're already playing in this field, and we expect to deal with it for a long time in the future. So with big data, we've got another segue here to that old technology tape, right? Those cassette tapes with all your music from the 80s on that you put in your little player. Well, we're actually talking about a little bit bigger, more robust tape. That's, of course, data tapes. And tape is not dead. And big backup is real. And with big data, people need tape and other solutions. So the market is in decline statistically. If you look at year over year sales and deployment of both drives and of media, we are seeing a decrease year over year in that. However, it's a huge market. HP, IBM, Quantum, Overland are big names in selling tape drives out there and populating lots of autoloaders in the world, either Spectralogic stuff, Commvault stuff, all kinds of stuff. And primarily LTO is the dominant format. 90% of the market share, which is amazing. We've watched a lot of different types of tape over the years, from Colorado and Quick 80 and Trevan and all that stuff through the Sony AITs, of course, the growth of DLT from Quantum, and then the progression to LTO, which is the Ultrium format, which is really the industry standard right now, with LTO6 with encryption shipping at 2.5 terabytes of tape, a little more than 5 compressed in some cases. This is the solution for the foreseeable future, with a roadmap already for LTO 7 and 8 moving forward. So tape is not dead, although it may be slowly dying. So what's happening to tape? Well, it is migrating. And as tape is slow, disk is still fast, where solid state storage is screaming fast. However, tape has its spot. What's happening in the world today is that we're seeing products that are labeled with all kinds of acronyms. VTL, Virtual Tape Library, that's basically the idea of disk looking like, acting like tape in libraries and utilized like tape. All the major vendors are selling VTLs of some sort. We are looking at D2D, which is disk to disk backup, which would incorporate no tape technology. D to T, which is disk to tape. And then, of course, we can't forget D2T, which is disk to tape, which is actually the more redundant solution where you're trusting both tape technology and hard disk technology for your backup and archive. So I know I'm throwing a lot of acronyms at you today, but these are all important in the industry moving forward and understanding where tape is today and where tape's going to go. And it is relevant in big data and the cloud because a lot of this data does need to get archived. Much of it can remain active data, doesn't need to go to tape. But with all the federal compliance acts by the US government and everybody else out there in the world saying you've got to hold your data for X number of years, tape is still an excellent alternative to managing large amounts of data in archive and likely will be around for a long time in the future. And big data in the cloud will help fuel that. The cloud. Segue once again, and here we are at the cloud. We did do a full webinar on cloud and data storage and data recovery some months back, but specifically, let's focus right here on just a couple of issues with a good reminder of how to choose a cloud provider following. So the forecast is cloudy. Get ready for your acronyms again. We've got SaaS, PaaS, IaaS. That doesn't sound so good, but that's how you pronounce it. SaaS. Are we confused yet? Software as a service, platform as a service, infrastructure as a service, and of course, storage as a service. Amazon Web Services, Microsoft's Azure, and VMware are clearly leading the pack as far as the technology that these cloud offerings are built upon. Those three platforms, as well as Red Hats and some other offerings out in the field, are really the basis for what a lot of these new companies who are providing cloud services are running their software on top of. Storage as a service specifically refers to cloud backup providers or data storage online. We focused specifically on that in that last webinar, and that list of cloud providers continues to grow with a few dropping offline as well. So it's always important that when you see cloud providers coming available, that you are very careful in choosing who you use, and we'll go through a checklist in just a minute as a reminder of how to add cloud data storage to your backup portfolio. And data security, let's not forget that data security is paramount to everything we do here at DriveSavers and everything that you care about, keeping the proprietary nature and the private nature of your data to only yourself. And data security is really important in the cloud. More data in the cloud, more risk of exposure, more news stories every week about another breach that occurred. Anyone that you choose, as far as a cloud provider goes, make sure that they are holding up the security to the level that you require so that if anything happens to one of these providers, you not only are protected with the data in their space, but you also possess other multiple copies of the data just in case they go away. So let's check in on that checklist once again, because this is a really popular question for us at DriveSavers these days. Although we're in the business of recovering data, we also like to tell people how to back up and protect their data. And if you're going into the cloud, go in with your eyes wide open. Think of these things in this little checklist of considerations before you go ahead and engage in contract with one of the cloud providers. And please remember that if a service is free,
it is free for a reason. It's probably not coming with a service level agreement, and your expectations should not be extremely high of what you deserve if it goes down. However, the paid services do offer contracts and SLAs. Design and implement a recovery and restore strategy first before choosing who you're going to use. And that incorporates multiple levels of backup before you get to the cloud consideration. That would be your attached or local backup, your either remote or co-location backup if you've got that, and also a cloud as another level. Whoops, sorry on the slide there. Seek a solution that fits your needs specifically. Everyone's got different needs for the amount of data you have, the retention you need, the restore window you need. Be selfish in this regard. This is your data, your backup. Do you require federal compliance? You'll know if you're governed under HIPAA. Be very careful there, or Sarbanes-Oxley, or any of the other data compliance acts. How long do you need to keep the data, and how available do you need to keep it? Determine the real total cost of ownership for the service, and weigh that against your other methods of backup. What appear to be very, very economical services for backup in some cases turn out to be quite expensive over time. Require encryption and understand their security. This is very important. It might be a little hard to digest everything they're selling from the marketing perspective on their encryption, but do your homework here and make sure the data is protected, not only in transit from your machine to their cloud, while on their cloud, and on the way back down. Know where your data is going. It's perfectly appropriate to ask where the data centers are located that store your information, and don't be surprised at the answer. Read the fine print, like every contract you sign. This one's about you and your data. Make sure you know what you're getting into. And really importantly, ask the hard question and see what that salesperson tells you. What happens to my data if your company goes out of business? Hopefully they give you a straight up honest answer and have something to back it up that gives you some trust and security so that you know that they're a good choice for your cloud provider. Well, we're going to wrap up here, folks, about 24 minutes into the presentation. Let's do a quick summary of what we talked about today. Of course, the solid-state drive market is growing in a variety of different ways, while the hard drive market is relatively static right now. We've got cheaper prices, we've got new technologies and form factors, new applications for solid-state drives and NAND flash, whether it be the new smartphones that have just been announced or the new high-end enterprise-based solid-state storage that's going to be running all those cloud provider servers we were talking about. Big data in the cloud, exponential growth in the data gathered, processed, and hosted for the ultimate goal of giving you that little tidbit of information you're looking for. Security is always a concern. It doesn't matter which service you're talking about. Amazon Web Services also went down again recently. Microsoft also went down recently. Remember that availability is important and security is important, no matter who your cloud provider is, whether it's just for your data storage or you're running your entire business on it. And of course, you still need to back up. And we are still here 24 hours a day when you need us. For all the talk that we do here in these webinars about data protection and what's going on in the laboratory, we hope that some of it turns into education so that ironically you don't need to use our service. But you will be aware of what we're available for, what we're capable of doing, and in the event that you ever do lose data, we're always here ready to help you or your customers. And finally, of course, and importantly, is the freebie at the end of the webinar, which John Christopher will run for us here today, possibly in a moment. And I'd like to give that away.
Some Q&A going on here.
Oh, I'm sorry. We're going to Q&A first before we do the raffle. That was my bad. Let me see. Let's advance to that slide and let's get there. Okay. We're going to do our question and answer first, and then we're going to come back around and do our raffle.
All right. Our first question, this individual would like to know a little bit about how data will be recovered from SSD, how DriveSavers does it versus working with hard disk drives when it fails.
Well, it's an excellent question, of course. Solid-state drives require completely different technology in the laboratory to recover them. That's where we do a lot of our work in research and development, specifically working with the controller manufacturers of the solid-state drives, SandForce LSI being a popular one. So it's a different set of tools that's required and a lot of technology that we are developing on the fly as the solid state drive market goes. And this is a great time for us to make a quick announcement that, in fact, moving forward, we'll probably be doing a lot more solid state drive recovery, and DriveSavers is now going to offer free evaluations on solid state drive recovery, just like we always have on hard disk drives in the past.
All right. Here's a question about something I know nothing about, which is any news on crystal storage? Like, is that Quakes? Do you know what that is?
Excellent question. I am not up to date on what's happening in some of that more exotic storage right now, although I am quite familiar with some of the holographic offerings of the past and some of the other prism-driven type reading mechanisms. I'm not sure if that's what you're referring to here, but there are a couple of technologies being thrown around kind of for future of stuff that will last forever. But that's a great reminder for me to go offline and do a little homework. And if you provide me with your email address, I'd be happy to provide you with some feedback on it.
All right. Here's kind of a long question. As people move more and more into the cloud, would people move away from services like ours? I'm not sure what that's referring to. Data recovery services or professional services or storage devices and that kind of thing. He mentions Dropbox or SkyDrive, something like that. And I'm not real clear on the question there that you have, Jonathan Solis. If you could elaborate a little bit more again and re-ask that question so we get a little bit more detail. Let's go to our next one and ask about D2 cloud and tape and human intervention.
Sure, that's a great question right there on disk to disk in the cloud. Well, we're never going to eliminate the human intervention because tape jockeys, who are the people who sit in rooms and flip tapes in a data center, are just like the guys who sit in a room and flip hard disks in a data center. They fail the same way, and you need human intervention in there. Now, if you're talking specifically about configuration of tape backup or things like that, it always has been complicated with tape software. The main reason for disk to disk, I don't think, is to take some of that risk away, but more so to implement faster and more available backup. But it's a great question moving forward. I think that unfortunately the human factor will always be the weakest link in the storage chain, and we will find ways to eliminate that, but it'll always be part of the equation.
All right. Our next question, is there a specific amount of PBs that are determined what system is considered big data?
Excellent question about how we define big data and the number of petabytes or exabytes necessary. Nah, there's no pure definition for it, and it's not really a capacity threshold. It's, again, more of a marketing term than anything. So it's really just talking about huge amounts of structured and unstructured data, too big to fit in a single database per se. Great question, though. Thank you.
All right. Where's the data on a hybrid disk?
Ooh, good question. Where's the data on a hybrid disk? Different technologies are doing it differently. In the Seagate example, they have a pretty good press release. You can go look at Seagate's page today if you want to see what they're talking about how they do it. But Intel, for example, in the caching, does it a little bit differently than Seagate does. Seagate's using MLC flash in their drive right now to move that data or highly available or recently used files into flash and then leave the lesser used stuff over on disk. Apple's implementation is using kind of a 4 gig buffer to move data back and forth in their build to order option from the flash to the disk. And the Intel operation actually preserves the data both on the flash card and on the disk simultaneously for a period of time. So different approaches, each one does it a little bit differently.
All right. Here's a question about encrypting data before transfer to a system. It says without security.
Yeah, so I assume you're meaning here you want to utilize some cloud provider that is not hosting all of their own security, and that you want to take the responsibility of securing the data before sending it to them. If I'm understanding the question correctly, that's very generous of you to want to be responsible wholly for the security of the data, but I would tend to say I'd look a little bit closer at that provider and possibly not using them if they don't have the infrastructure in place to provide encryption and end-to-end security for you. I would question why you're using that particular cloud provider.
He comments here. He says that some don't allow that.
Okay. Some don't allow, well, I'm not sure the comment, don't allow you to secure the data first before sending it to the cloud. If you can answer that quickly. Encryption on, you're talking about encryption on their site. Understood that they don't allow it on their site. Well, this is a question that probably is better for a longer conversation about what your motives and goals are in using the cloud. I'd be happy to take the conversation offline if you'd like. Send an individual message over to myself or John Christopher, and we can do that, okay? Thank you.
Any other questions? Any other questions that we might have from the crowd? Otherwise, we're going to have to give away a drive. Oh, here's a question.
Oh, an excellent question coming in at the end there. What is the best way to wipe an SSD? This is an excellent question, and I'll try to give it 1 minute instead of the hour it needs. Data sanitization. Currently, if you're interested in this topic, look up the concept of crypto erase, which is now becoming a standard on solid state drives, where you can instantaneously discard the global unique encryption key and therefore lose the key and sanitize the SSD. It does not necessarily eliminate all of the data per se, but with that key gone, the industry is accepting that as a standard. Also look at the non-volatile memory workshop group from UCSD, who has put out quite a bit of information on the topic of sanitization of flash.
All right. Any other questions?
Oh, I'll take a quick stab at that one. We'll give them credit on this one. The versus hard drives, the quick answer on wiping hard drives is that it still requires an actual erasure of all the data at the physical layer, at the block layer. And the best way to do that, if you want to keep the drive operational, is a multi-pass physical overwrite of the actual data space. If you do not need the hard drive to be operational, your best two steps are first degaussing the device with a properly powered degausser, and then physically destroying the device by shattering the platters. That'll be a good way to do it. And we'll end on that question. And